All right, in probability, there's an important concept called permutations and combinations. Today's lesson is technically about permutations, but to really get it, you need to understand the difference between a permutation and a combination. So here's what I'm going to give you. Give me 3 redneck names. Billy Joe is an excellent one. Jim Bob, I'll give you that. Not redneck enough. Cletus, I like that one. All right. Billy Joe, Jim Bob, and Cletus. Now, I'm going to go with 3-letter abbreviation, or just B and J and C. And so there's 3 rednecks we can choose from. Now, if I were to put and have my rednecks on display, and I only wanted to put 2 of them out at a time, okay, then I could have like 2 spots, and I could either have J and C, okay, and is that different than C and J? That is, some people said yes and some people said no, and that's exactly the point. If the order matters, then it's a permutation. In other words, if J and C are different than C and J, then the order matters, and then that's a permutation. And I'm going to say this annoying little saying that's going to help stick it in your head. I'm going to say order patterns. Order matters. Order patterns. And the P gets thrown in there, and the P makes you think, oh, permutation. Okay. Now, if it's a combination, then obviously the order doesn't matter, because that's kind of the point. All right, so remember, just try to make sure that you know if the problem, whether or not the order patterns or not. All right, so now, if JC is not different than CJ, then the order is irrelevant, and it's a combinations question. All right, so then JC is one of the combinations. I'd like you to make me a list of all the combinations that there are. Combinations, not permutations. That would imply rearranging the letters JC to CJ. I don't want you to do that. Hopefully you came up with J and B, which I'm going to put in that order for some reason. And last, I'm going to go with, what is it, C and B? CB. All right, so I have my 3 different choices there. If I had reversed them, do you agree that I would have 6 choices? Because I would have B and J, and I would have C and J, and I would have B and C, and that just doubles my total. So if I care about the order, there's going to be more answers. That's a permutation. The order matters. The order matters. All right. Then one of them is duplicate because there are 6. All right, good. So now, if you have a problem where the order matters, that's a permutation, and there's a way to do it on your calculator. Let me show you where it is. Grab your graphing calculator. If you don't have it out yet, get it out. If you want to borrow one of mine, I happen to have 6 sitting up here right now. They're lonely and wish somebody would hold them, and well, I'll go on from there. Now, on that calculator, look for the math button. Math. There is a button called math, believe it or not. You'd think the whole dang thing's about math, but just one button says math. If you do math, then you'll find something that says PRB underneath the math option. So I'm going to go here and show you. Once you hit the math button, you got this. Go over to the far right. You see how the PRB there? Estimates for probability. Take a wild guess. 1, 2, 3, 4, 5, or 6, or 7. Which one is the P one? Number 2. That's the P. The C one for combinations, as opposed to P was for permutations. C is combinations. That's number 3. So we're going to use those in a minute. Now clear out of that. Go back to second, quit, and then clear, and get your screen completely clear and blank and ready to go. Okay? Now, would you agree that you had 3 rednecks to choose from? All right, so that's 3. Type in a 3. That's what you start with, is how many you had to choose from. Then you have to decide if the order is going to patter or not. All right, so in this case, the order didn't matter. We didn't care if we rearranged them. So if the order does not matter, it's a C question. Hit math. Go over to probability. and then arrow down to the C, or you can just hit a 3. See how it brings up that NCR thing? All right, that sends its combinations question. And then I was only picking out 2 of my rednecks to put on display. Okay, and so I'm going to hit a 2. So it's 3, choose 2 is the way I'm going to say that for shortcut for now. Enter. My answer was 3. There were 3 ways to do it. Now, that one wasn't hard. You could have done it in your head, right? But here's one that's just like it. That'd be a lot harder, and you use calculator for it. Let me count how many there are of you. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. There are 30 of you in here right now. Let's say that I was going to pick out 3 of you to put on display and set you on the shelf up there, okay? So I'm going to take 3. Do you get that there's lots of combinations of you? And if the order does not matter, like if I have, you know, Bob, Jim, and Sue, and I don't care if it's Sue, Jim, and Bob, it doesn't matter what order they're in, just 3 people makes a group. That's called a combination. Did you already type it in while I was talking? How many did you have to begin with? 30. What did you use, C or P? C. And then it's 30C what? 3. 30C3, what did you get? 4,060. 30. C is under math. C is the 3rd one down. 3. There we go. 4,060. That's a lot of different ways. Holy cow. Now let me give you an example of one where the order would matter. Let's say we have a race. We get all of us out to the parking lot, and we have a race, and we go the length of the parking lot. All of us. Okay? Now let's say we're picking 1st, 2nd, and 3rd places. They get prizes. 1st place, 2nd place. Well, by the way, who would probably win? Who's really fast? I'm pretty fast? All right. Yeah. We're not talking about physical speed. All right. I wasn't talking about speed of sense of humor. That'd be. All right. So, if we had a race in here, obviously, other than the fact that some of you have an advantage over the others because you're fast, we could have a lot of ways that we could have it happen, right? Let's find it out. Use your calculator. Got 30 of us. How many different ways could we finish 1st, 2nd, and 3rd? Well, it's pretty much 30. Does the order matter? Yes, it does. So 30P3. Tell me a way bigger answer than 30C3 was. See how many different ways there is? It's insane. Yes. I did not. I'm not racing. I would hurt myself. I don't want to do that. Okay, so we go 30P, what's in our math? And then it's a P, it's the 2nd one. And then there's how many places? 3 places. Enter. There you go. 24,360 different ways that we could finish. It doesn't seem, it's kind of counterintuitive. There's just so many different ways. Now, could I do this a different way? Absolutely. I'm going to show you the on-paper way because this on-paper way actually is better than the calculator sometimes. I'll show you what. Would you agree that there are 3 slots? Our 1st, our 2nd, and our 3rd place slot. Then how many people could win in that 1st place spot? Okay, yes, you've got a point. Only one person can win 1st place, but there's 30 people that could be in that spot, so I'm going to put a 30 there. Do you get how if the person, I choose that person for 1st place, that they can't then do the 2nd place? So then I times by how many choices do I have for the 2nd spot? 29. And the 3rd spot? 28. So 30 times 29 times 28. Take a calculator. Type it in quick. 30 times 29 times 28. What's it come to? Same exact thing. All right. So the point is, this blanks method is fine. But when you have to do it like with 7 spots or 8 or 10, the calculator way is going to be way easier. You'd rather type in 30P7 than to have to draw all these blanks out. So the calculator is good for some things. Now, how about the blanks? What are they good for? They're good for this. Let's say that we know there's a kid. I won't name him because we're out recording here. That we know is going to probably win. Then we're going to say that there's only one choice for 1st. Only one choice for first. And then there's 29 choices for the next and 28 for the next. Get that? Like if we had some kid in here was like the national champion, you know, runner or whatever, you just know they're going to finish first. We're going to put them as number one. All right. Let me give you another example. Do you notice in movies at the end of the movie they roll like the credits, who was in the movie and stuff? Did you know that it matters who gets shown first on that list? That's actually in the contracts for these actors. That they get top billing at the end. They get listed first. That's like part of the deal. Like, so if you're like Jim Carrey and you're in a movie and you want to make sure that everybody knows it was you, you're listed first on the credits. Okay? First versus second versus third. And if you think about it, it's never alphabetical. It's always in the order of how popular the actor is. And so if you got like a no-name actor or actress that got their first shot in a movie, they're going to be listed later than the famous person. So sometimes not even the lead character is listed first. Yes. Yes, and sometimes it'll say in order of appearance. So you're right. But a lot of times the actors and actresses, they kind of got big egos and they want to be like listed first. And sometimes they'll even have deals where it's got to like say, you know, a Sylvester Stallone movie, right on the cover. Like, so it's their name. All right, so let's say that we have a bunch of actors and actresses, and we got this one person who's a prima donna and says they have to be first. Well, I only got one choice for that one. See what I mean? All right. And then you times by however many others. So let's say there's a total of 8 actors. One of them has to be first, and there's 7 choices for the next one. All right. So those blanks can be kind of handy. The main thing here is how many choices do I have, and I multiply them. There's a theme, that is it. You need to take the choices you have and times them together, and it gives you a total. Notice these are not probabilities, but they can help us figure out probabilities because they'll tell us how many different ways there could be. All right? So if we run this race, and we actually have a result, and it's you 3, win first, second, and third, we can know the probability of that. There was 24,000 different ways that it could have happened. So what's the probability? 1 in 24,000 that it would be you first, you second, and you third. Okay. So, and that's not even taking into account some of you are going, yeah, she'd never beat me. I'd be, you know, that doesn't even factor in your abilities, because that would make the problem much more complicated. All right, go back to the notes and find this page, the very first page. Remember what I was saying about choices and multiplying them? How many choices are there for the shirts? 4 choices for the pants? It is as simple as 4 times 3. There are 12 outfits. Now, do you have to make a tree diagram? No. But it's just a reminder that trees can do almost everything in probability. It's just a pain to make them. I could say, here's my choices for shirts. And then after I pick the red, blue, or green, or yellow shirt, then I have a choice of 3 different kinds of pants. You know what I mean? Well, couldn't I just multiply my choices? Yup. 4 times 3 makes 12. All right, moving on. How about this one? 4 shirts, 3 pairs of pants, 2 different kinds of shoes, 2 necklaces, and 1. Just multiply them all together. 4 times 3 times 2 times 2 times 1. Now, who's got a lot of choices? Well, McDonald's has a lot of choices. Go to McDonald's, don't you have like a bazillion choices of what you could order? I'll give you an example. I went to Smashburger yesterday. Good hamburgers. Anyway, I chose not to go to McDonald's because even though their hamburgers are a lot cheaper, because, you know, sometimes you want to pay more money and get a really good hamburger. Well, McDonald's has many, many choices. Think about it. That's the very first thing that you would probably order, maybe your main meal, like your main meal, can't you get like, there's like 5 different kinds of hamburgers, there's like 6 different kinds of chicken, you could get a salad, so there's like 12 choices right off the bat. Then what's the next thing? People usually get like, do you want fries with that, right? So the different kinds of fries. Now actually McDonald's only has one kind of fry, but they now are offering more healthy choices. So you could get apples with that, or you could get, well, there's a lot of different things you can get. Next thing, you got choice of drinks. And you got like 7 different kinds of drinks. Do you know that I've actually done the math on this? You can have over 1 million different meals at McDonald's if you multiply all those choices together. Does it mean that they will all taste significantly different? No. All it takes is to have an orange pop versus a Coke, and you've made the meal different. Okay, so that's not a huge difference really, but you can have over 1 million. Yes, I did factor in the size, small, medium, and large on most of the different things, right? So you end up with 1 million different meals that are possible when you factor in all those different choices being multiplied. All right, would you really want to draw a tree for this one? Oh, ugly. Take forever. So luckily we don't have to. We just multiply the choices. It's called the counting principle. It's got a fancy way to say it in a mathy sort of way, and I'm not really into that. I've explained it to you already that you got these ways to make a choice, and you use the product of them, gives you the total possible outcomes. All right, let's move on. So license plates. One way to do them that's really smart is with blanks. Did you get that there's 6 blanks on this? There's 6 different things that you could have had. There's 6 different spots on the plate. In Minnesota, there's 7. If you want to get a personalized plate, you can get a personalized plate. Like, let's say that everybody knows you're the X monster, XMSTER, or something like that. Okay, you can get that. There's certain ones that they won't let you have, if you think about it. They're not going to let you say swear words, and they're not going to let you say things that are inappropriate, or like "you are an idiot." It's something you can have as a license plate. They actually have a list of naughty license plates that they will not issue. Yes. Very good. Do you know what the W stands for if you got a W in front? Those are called whiskey plates. Yep. So if yours starts with a W, it's kind of subtle, and you'd have to know this, but if your license plate starts with a W, it probably means that somebody in your families get picked up a DWI or 2. Doesn't usually happen to you in the first one, but if you get enough of them, then they'll make you have a plate that has a W in front, which means any cop following you is going to watch you really close. Like if you're doing anything funny at all and your license plate starts with W, they know to keep an eye on you and probably going to pull you over and check. Yes? Okay. What exactly what it... Hey, oh my gosh. Kicking gas? I got you. Uh-huh. Uh-huh. I got you. Oh my gosh. And I bet you that if they had thought about it. All right. I got one that says Go Epic on it. It's in one of the insurance companies that I work with. It's called Epic. And so I went with Go Epic as one of my plates. So I know there's 1, 2, 3, 4, 5, 6 for sure. But in Minnesota now they've changed it to 7. And they've got, they've got a... they've got, what is it, 4 numbers and 3 letters? Who knows one? Anybody know your own license plate or one of your ones in your family? Go ahead. And then what? All right, and I'm going to change it just a little bit. So it's like that. Okay, maybe it's still 6. I thought it was 7. I thought it just changed to 7, but in between, in the middle? Okay. Maybe the little symbol is the country. Yes, sir. It's perfect. Yep. Oh, egg. I gotcha. Egg is an agriculture. Egg 001. That's pretty awesome. I had a random one assigned to me when I was a kid, and it was the Fez 470. I still remember it. Fez 470. Right, he is a little weird. Anyway, Fez 470. Now, how many choices were there for this? There were 26 different letters they could have picked there. 26 for this, 26 for this, because they can repeat definitely. Next, 10 choices for that. A lot of people say 9, but it's actually 10. Count as 0 as an option. Okay, 10, 10, and 10. So if you multiply 26, 26, 26, 10, 10, and 10 are the choices. That's how many license plates comes out over 17 million. Why would you need 17 million license plates? Did you know there's 5 million people in Minnesota? And all it takes is to have some of these license plates getting ruled out, like all the ones that start W, okay? Or all the naughty license plates. Nobody wants the FU whatever machine. The O would look like a 0, wouldn't it? Yeah, like that for a 0. That's a good point. In a big state, it makes a difference because, like in California, they have 55 million drivers. I guarantee you, they don't have only 6 slots in their license plates because they need 55 million plates just to have 1 car per person. Now I know it's not necessarily 1 car per person, but a lot of your families have more than 1 car per person. You know what I mean? Like you'll have 2 people all in 3 cars. So you have to have enough for at least a 1 a person, I'd say, on average. Yes. You mean the repeat letters? Yes. You mean the exact same plate? No, absolutely not. That's kind of the whole point of these things, is there's only 1 assigned. And for cars, every car in the whole United States has its own separate number. Did you know that? It's called the VIN number, the vehicle identification number. Only 1 car has that number in the whole United States. And in fact, I believe it's worldwide, but I don't want to absolutely positive. I'm not positive of that, so for sure. And that's 17 digits, and it's the numbers or letters the whole way. So they usually start with like 1, and then they go with J, and but it can be a lot of different things. So if you think about it, if it could be a number or a letter, your very first spot could be 26 plus 10 is 36 choices for the very first spot, and there's 17 of those. So you go 36 times 36 times 36, 17 times. That's 36 to the 17th. It's an insane number because every single, we're talking like, you know, license plate gets reused year after year after year. You know, like one person uses that same plate on the car over and over and over again. As soon as they build another car, they throw out an old one, but that never gets reused. You know what I mean? Like that VIN number, that special number for that car will never ever be used again. So they have to have a lot of these numbers. Okay, enough about that. I just want to make sure you understood. I tie this to the real world. So how many different license plates are possible? Well, let's explain. This blank method is going to be really powerful. And you just say 26, 26, 26, 10, 10, 10. All right. What's probability? Now, this is important and different. That is not a probability. That's a total number of plates. What's the probability a license plate has no repeated letters or numbers? Before I answer your question, I want to answer this, unless it's about this. Okay, so just hold on. What's the probability that it has no repeated letters or numbers? Well, this is the total number, and what's like 17 million something? Okay, 17560, something like that. That's on the bottom. That's all the ones that were possible. The probability that has no repeated letters or numbers, well, then I need to know how could I show a plate that doesn't allow repeated numbers? And I have a different set of 6 points. Woo. Lively marker. Different set of 6 points. And now there's 26 choices for the first one, but 25 for the next one, 24 for the next one, 10 for the choice of a number, and then 9, and then 8. All right. So there's a lot less of them then, right? Let's move on. I want to get off of this license plate thing and on to other stuff. Please turn to example 2. This one's more like the one we did with the calculator. We got a total of 5 kids here. 3 boys, 2 girls. How many different ways can the 5 racers place? We got 5 racers. Does the order pattern? Yes. If it has first, second, and third, that's a hint that the order matters. P, and then how many places were there? So you got 5, 6, and you're done. Who's done already? Raise your hand if you're already done. Awesome. Tell me the answer. 60,000? 60. Sorry. Use those big ones. 60. Okay. How many different ways can the 5 racers place if a girl needs to finish first and third? Okay, this is why the blanks are really good. Because you can't do something like that with your calculator. But you can do it with blanks. How many choices do I have for that first spot if a girl has to be there? There's only 2 girls. 2 girls, right? So 2 times... Now, does it say that a girl needs to finish... if there's only 2 girls, do you get that the other girl has to be here? And there's only one choice for that girl? See what I mean? Just wait, I'm not done yet. And then, there were how many people could be here? Only boys, because the girls are finishing first and third. So how many choices for that spot? There's only 3 boys, so that's 3. So 2 times 3 times 1, it is... Because this was girls, right? If I choose one of the girls for this spot, then there's only one left. Yep, it changes things because that first spot's already taken, that's already a person there. Yeah. All right, and the last one. This is the hard one. What's the probability that a boy finishes second? All right, probability. Probability is not how many total. It's what you want over what's possible. Well, what's possible is 60 different ways. There are 60 different ways that are possible. We already know that. Now, if we change this question to what's the probability that a boy will only finish second, or the only boy finishing will be in second place, then it'd be just 6. Because this was the one where boy was second and girls were first and third. So then it'd be 6 out of 60. It's not really what it says. A boy finishes second. Let's just go through all the spots. How many choices do I have for the... There's 3 slots, right? How many choices do I have for the first slot? Couldn't any boy or girl be in that first slot? Yes. There's 5 choices. But a boy has to finish second. How many choices for that? There's 3 boys. So there's 3 choices. And then the last one is, could be anybody, again, right? How many, it could be a boy or a girl, but I've already used up 2 of my spots. So, you got that? Here I could choose from anything. Here I could only pick boys, and here I have to only choose 3 because there were 2 people already picked out of my group of 5. All right. So, 15 times 3 is 45. So, I believe I've got that correct, unless somebody can show me proof that there's some smarter way to do it. I think these get tricky. They really do. I mean, these are ones, I can tell you there are math teachers in our math department who teach calculus. Because it's the highest level math that we offer at the school, and they will say, I don't know how to do those. Like, probability has all these different rules you don't use very often. So it's hard. Okay? Does that mean you can't figure it out? No. But it's not used a lot in higher level math unless you're in actuary or something like that. And so you're going to get the most probability in this class that you are in any other class. This is like the highest level probability in the whole school is in Algebra 2 when you're taking it. Okay, I don't want to go through all these examples because, frankly, you've got some homework to do, and I don't want to take all your time to do homework practice. So let's do the homework. Grab your homework and we'll start it together. Yes, sir. You got me. Thank you. All right, so let's get to the homework, though, for right now. Find this worksheet. Looks like this. You are going to be allowed to skip problem number 4 because I felt like the worksheet was a little too long. That doesn't go for any other classes, but it's in my classes anyway. You may skip problem 4, part A, B, C, and D. My deal is that I always feel like the homework has to be reasonable. If I really expect you to have it done, then I have to keep it reasonable. And this one's a little too long, in my opinion. So we're going to go back to number 1. Remember that when we get there, number 4 is a skip. An 8-volume set of reference books is kept on a shelf. These books are used frequently and put back in random order. So basically, you got a bunch of jumbled up books. How many ways can the 8 books be arranged on the shelf? Think of it as 8 spots on the shelf. Now, can I put the same book in 2 spots? No, so I got 8 choices for the first one, but then I don't have 8 choices for the next one, right? 7, 6, 5, 4, 3, 2, 1. Now, if you'd rather, you can use your calculator and say, I have 8 books, and does the order matter? How about this? If the order didn't matter, then as soon as I put all 8 books on the shelf, I'm done. It doesn't matter what order they're in. Okay? So if you want to say the order doesn't matter, there's only one way you can put them on the shelf. You can put them on the shelf or not put them on the shelf. You know what I'm saying? The order does matter. 8P, and then how many spots are there for books? If you do this or you do this, then you get the same answer. Somebody verify that for me, make sure I'm not going crazy. I think I'm right. Try 8P8. What is 8P8? 40,000 what? Or this, I bet you anything. Multiply it out. There's one more way. Does anybody know what the exclamation mark means? You know what it means. Do you know the official name for it? It's called factorial, but what does it do? So like 5 factorial, the exclamation mark, is also on the math button. It means 5 times 4 times 3 times 2 times 1. That's what exclamation mark means. Learned a lot of little stuff today. So if I wanted to, I could do 8 exclamation mark on this. Because that's what 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 is. You do 8 with that exclamation mark, it'll equal that. All right. Okay, rest of the time is yours to crank these puppies out. You can use blanks a lot today, but not on all the problems. And you're welcome to use a calculator anytime you want to do P's or C's. Just show what you did. So if you did like 8P3, write that. And then the answer. Remember, P is for order matters. C is if the order does not matter. And I know they can be confusing. This first one, it really kind of seems like the order doesn't matter, but it does. Otherwise, if you just put all the books on the shelf, then you're done, and you can't rearrange them because the order doesn't matter. The answer would only be 1, which would be ridiculous. All right.